Welcome to today's webinar. We'll be talking about point clouds and Hoops Visualize. I have Guido, our technical fellow, and Marco, our product manager for Hoops Visualize, here with me today. First, Marco will talk a little bit about point clouds, and then Guido will go a little bit more in depth. So without any further ado, I will hand things off to Marco. Marco, over to you.
Thank you, Gabe. So first of all, welcome everyone. So my name is Marco Salino, and I'm the product manager for the Text of 3D visualization technologies, which are Hoops Visualize, Hoops Communicator, and soon it'll be a new our Hoops Luminate, our advanced desktop rendering solution, which will be, just a bit of a teaser. It will be communicated later. We probably, most of you know, we bought Red SDK, almost a year ago, and now we are incorporating its technologies in our portfolio. So just very quickly, my background: I joined Text of 3D about a year ago. Previously, I worked with Bentley Systems. I was one of the MicroStation product managers for about 7 years, almost 8. And my areas of responsibility there were 3D modeling, data interchange, rendering, and a bit of some of the geometries and property management. And so I kind of came to work with point clouds, mostly trying to incorporate in this type of data into the DGN file system. Also try to get our tools to work with them, and also had a little bit of a relationship with the one of the photogrammetry product that Bentley was producing at the time. So just moving about point clouds. So why are these becoming important? So first of all, we're seeing that they are becoming more pervasive, and this is in many industries, right? Of course, there's an obvious use before, or an obvious use, sorry, is in the AC or in civil engineering for surveys to try to get scans for lane infrastructure is an example. You can use photogrammetry, but they also are becoming very important in manufacturing and in many other industries. So beside having more point clouds application or use cases, we're also seeing that the data itself is becoming larger. So we get higher resolution scanners, which are becoming more common and affordable. So you have bigger file with more points, the detail is becoming more fine and precise. So what it means is this is kind of a demanding for system with higher performance and efficiency. Many more points than you normally used to have, and we need to be we need to be able to handle them with efficiently and with the right level of performance. Point clouds, I mean, some of the consumer devices like phones are coming out with small LiDAR scanners in them that can produce point clouds. So they really are becoming more common in everyday's life. So what can Visualize do with point clouds so far? So when Visualize was designed a few years ago, we kind of the idea was to be able to handle any arbitrary size point clouds file. So there's no kind of hard limit on what we can handle. Of course, as for all the reasons we said before, having larger data files, data sets, sorry, it is becoming maybe not as easy to work with huge files. Also, Visualize, can't read natively all the formats that are around for point clouds. So there have to be conversion for us in order to be able to work with this, to import and work with this data. So the way it works, I mean, we've got expert here that you can, Guido and Mike, you can probably correct me, or they can give more details in later on. But basically, we had another core external application where they can handle this data, and the way it's been happening so far is that the data has to be imported into this OOC through a file conversion. So this, of course, as implies having a conversion can take some time. And also, up until now, this workflow is only available for Windows. So it is not available in all the platform that we currently support with Visualize. So what are we planning to do for Hoops Visualize 2024? So the next major release is to improve this out-of-core workflow, right? So there will not be any more need for a file conversion, but the data is going to be injected into this out-of-core application via an API. And that also means that we're going to have this workflow available for all platforms, right, including mobile. And also, this should bring us a sleeker and more efficient workflow in all these cases, especially when maybe your devices are not as performant as they could be with large files. So, in what are we thinking of doing for the future? So, past 2024. First of all, we want to get feedback on what we have been doing for 2024. We're looking at adding new formats to the point clouds like the E57 and LAS. Again, based on feedback, we'll look at further optimizing the point clouds workflow and the way we deal with the data. And of course, we'll keep monitoring market trends and new technologies to make sure that Visualize is kind of up to the game with what's happening on the market. Okay, and with this, I think I'm finished, Gabe. So I will leave it to Guido. That's okay.
Great, thank you. Thank you, Marco.
Okay, yeah, so I'm going to go a little bit more into the technical side of things, a little bit of a recap what Marcus was talking about, but with a little more technical detail. So let me share my screen here. Give me a second and start the presentation. You should see my first slide coming through. Okay, great. Yeah, so as I said, I'm going to give a quick overview of the currently available functionality pertaining to point clouds in Visualize, and just a quick side. We're going to talk about both 3DF and HPS here, right? So we have a few customers still on the old version of our library, and most of these topics relate to 3DF and Visualize. So most of the source code I'm going to show is HPS. So quick overview of technology, then I'm going to detail the old offline OOC workflow that Marco mentioned, where you have like a standalone executable to convert point cloud data to like a very special format. And then I'm going to get into describing the new workflow and what are the improvements there and why that makes sense. And then at the very end, I'm going to have a demo. Okay. So point cloud features. So just in general, visual, even before Hoops, we supported out of core point clouds, Hoops could always visualize point cloud data. And over time, we have also implemented some features that are just generically useful for displaying point cloud data. And it's important to note that you don't have to use this out of core functionality for huge point clouds to use point clouds in Visualize. You can read all these formats that we support, PTX, XYZ, or PDS, or generate your own point cloud data via the API, and then display it just as points. So that applies to OOC and non-OOC point cloud data visualized through Visualize. So we support point rendering, of course, with point colors and intensities. We support splat rendering, which is basically rendering each point as a sprite, and that makes especially thin point clouds look a lot more solid. I'm going to go into a little more detail on that in a second. We have the special IDOM lighting mode, which essentially fakes like lighting on a point cloud, especially useful if a point cloud doesn't have any RGB colors set on it to make it a lot more three-dimensional and easier to parse visually. There's a feature for automatic vertex decimation that sits aside of our frame rate technology. It's a very simple function call. You can just reduce the number of points that are getting displayed at a given time. It's kind of a cheap way to improve performance. And yeah, we have support for these basic support for these like ASCII-based point cloud formats. And as I said, Marcus said this, but it looks like there's more to come in the future. I think we did receive some requests for other formats, so that's definitely on the agenda. And then, of course, we have this OC support, out of core point cloud support for huge point clouds that go far beyond like 10, 20 million points, really potentially into the billions of points. Splat rendering. So that, just a little more detail on that. It's pretty self-explanatory if you look at the picture. So normally a point is rendered as a single pixel. But with this mode, you basically have the option to specify a sprite with different types. Usually, you want to go with a circle. You can define if you want to have the sprites get larger when you're moving through the model. And so you see here the basic code to get this working. It's pretty straightforward. It follows like the other, just generally how to set attributes in HPS. You have this marker attribute kit. Again, you define the size of the sprites in the various units. You define this as sprite symbol, and then you just apply that marker kit in this case to the view segment. And again, the effect is pretty clear. It comes at a, obviously depending on your hardware, you might see a performance hit, but it's rendered very fast. It's behind the scenes in the shader, so it should be. My experience is that its performance is good when enabling that, and it certainly makes sense. You just have to make sure that the sprites are not too large or it's a little. It has some problems. Item lighting, that's another feature. It's a little more subtle, and again, in this example, you see the difference, but it's not too pronounced. So it really just adds some fake lighting intensity based on the view angle to a point cloud, and especially again if the point cloud doesn't have any colors or intensities attached to it, then that gives really makes it look a lot more realistic and three-dimensional. And once again, it's a straightforward process. In this case, it's a post-processing effect in HPS that you can just essentially enable. There's also a back color you can apply, but I haven't really seen that have any effect on most data. Maybe later in the Q&A, I can ask Mike if he knows what this does, but at least for the models that I tried, it didn't really make any difference. So normally just turns out item lighting on and it will do its trick. And again, the effect will be subtle if the data already has RGB colors associated with it. Okay, so now let's go to the out of core. And just a general recap of that. It's really designed, I mean, I think it's over 10 years old, 10, 15 years old. So it's been designed like quite a while ago when memory was still much tighter on your typical laptop or desktop or even mobile device. And also the general performance was much lower. So it was developed at a time when we really when those things were really at a premium. But it's still at the core of its functionality, and it makes still a lot of sense even today. So it's designed for very large point clouds, above 50, 100 million points. In that range, it makes sense to use out of core. It requires this pre-processing step. So it takes a while to compute this data. If you have a very large point cloud, it can be hours, theoretically, where it basically churns and optimizes the point cloud and makes it sensory massages for rendering. And then during the actual rendering phase, it's a special rendering mode. It's not just like loading an HSF file or creating some geometry in HPS where the data is inserted into the segment tree. There's still a segment, and it still follows these general guidelines, but behind the scenes, there's a highly multi-threaded process, churning and essentially loading and unloading data, putting and making sure that that there's not too much memory getting consumed, and you have control over how much memory that is. And in combination, working together with the frame rate logic, it makes sure that you're not going over that performance is adequate as well. And it's important to note that you can have multiple of these OC point cloud models simultaneously. That's a way to, if you have one point cloud and you want to add another, maybe it's coming from a dynamic scanning operation, that can be done as well. So it's not just a single point cloud you can essentially attach to, but you have multiple point clouds as well that you can view at the same time. Before we go into the actual creation of a point cloud, let's start with the viewing, which we have this new and the old way of generating point cloud data, but that is the same here for both. It's very easy in HPS. Just the way you usually load your data it might be Exchange data or it might be just an HSF. You just have this special OOC import option kit, and then you can just import your model. A good starting point if you want to use point clouds is the MFC OOC sandbox that comes with the HBS package. That has all the code that sets up, do the loading of the point cloud, sets up the OOC, the special operators that you have to use for selection and setting some of those options. So if you want to, that's a good way to kind of go through basically. Here, just for completeness sake, in this case, I also describe how to view an OOC point cloud in 3DF. Most importantly, make sure that multi-threading is set to full, because as I said, it's a highly multi-threaded process that's going on behind the scenes when loading point cloud data. And then you have to make sure that the HIO OOC is that HIO module for OOC is in your binary directory as well, so it can find it, and then the rest is essentially automatic. If you use MVO, you can just load the point cloud models just like any other data type. And for this, I would say the part viewer is always a good starting point to do your to test it out and to set the various options. That again it's all. It doesn't have any special OOC functionality, but it's all wired up so that you can just load and view the point cloud data. So now let's go to that pre-processing part. So again, as Marco pointed out, there's a separate executable that is only available on Windows that deals with taking a point cloud data in these different formats that we directly support, PTX, PDS, and XYZ, and then generating essentially a point cloud file out of it. And that happens, you can see that's the diagram from the documentation. There's a complicated process where it takes each point and organizes it in a spatial tree, and then creates a relevant segment and shells. And so it's a long-winded process that really is designed to optimize later the rendering, because there's no server, there's no like out of core server, like for example in Hoops Communicator we have a streaming server. All the loading actually still happens inside the application, but because the data is pre-processed on disk and placed in an optimal form, different files representing different parts of the point cloud, it can be read very quickly. But what you really need to know is that at the end of that process, you have an .ooc point cloud file, and you have you have two directories that represent essentially that point cloud data associated with that file. So so it's just to kind of go back to that. So you need a separate executable, and it only reads these three formats. That is, of course, a limitation, and it means that if you have your own point cloud data that you want to feed into the system, maybe you have your own reader for other point cloud formats, it's cumbersome because you first would have to write out these to one of these formats that we support, then feed that to this offline executable, then generate the data, and it just takes a long time. It's cumbersome, and it's not elegant. That was the main motivation we developed this programmatic approach. It came from a bunch of feature requests that we had from existing partners using our point cloud stuff, and it allows you basically to directly feed your point cloud data in chunks to the preprocessor. That's what it's called. And the preprocessor is essentially like it's a library version of that executable. It's still, and I mean, that's a very important point. It's still, and it's still a two-step process. You're still taking your point cloud data, pre-processing it, which will take some time. And then at the end, you still end up with this OOC point cloud file. The major difference is to the old approach is that it doesn't require a separate executable. That is all handled via this API. So that's important to understand. It's not really, it doesn't change anything. You cannot dynamically add points to the system and then immediately display them. You still have to go through this pre-processing. But what it really allows you to do is leverage your own point cloud formats or your own importers for point cloud data, and then use those to generate the OOC point cloud. And obviously that means you can do this on Linux, on a mobile device, or on any of the platforms that we support. This functionality is available, or is about to come out in 3DF, and as Marcus said, it will be in Hoops Visualize HPS in the 2024 release. Here's a quick, it's very straightforward. It's a very quick example. All you need to do to make use of this new API is include this. Again, this is 3DF for now, right? It will be very similar and analogous to in HPS. For 3DF, just include this additional header file, then create this preprocessor object, by giving it the name of the OC file. Again, that's a file that's going to live on disk. Then you have to set the culling. You have to pre-process your points and generate like the minimum and maximum bounding box of it for culling purposes. That has to be set up before you actually initialize the preprocessor. And then after that initialization you basically just add points, and you can add number of points. You can add 1 point at a time. You can add a group of points, and you can obviously specify the intensities as well as the RGB data for each point as well. And that's really it. You add this point, and then at the very end, you call export, and that's where it goes through his process of optimizing, and again, which can take some time, where it generates this optimized data on disk that you can then load exactly the same way as if the point cloud was generated with using the old approach with the OOC preprocessor executable. So really very straightforward and not much to it. Again, it doesn't really change the fact that you have to do some pre-processing first, and that you still have a two-step process, but now you have much more control over it, basically. Just to quickly mention a few other features that are part of the OOC point cloud stuff that you might or might not want to use. They're a little tricky to use, I would say, but can certainly be helpful. There's this concept of delta files. So if you have an existing big point clouds and you want to delete parts out of it or make other modification, I think it's mostly going to be deletion. You can do that by generating a delta file with that change, which is then essentially put on top of the existing point cloud. So you're not really changing the existing data, you're just adding additional information to it that makes it possible to then, again, without having to regenerate everything, make modification to the existing point cloud. So that functionality is there. There's point query and filtering, so you can get access to what points are currently in the system. You can query those points. You can filter out certain points based on if they are already loaded or not loaded, and other criteria. We have a group of special selection operators because, again, point clouds might or might not be actually locally available so from a selection perspective, they might still be on disk and not loaded. So we need special selection operators that can handle these cases. And yeah, and I think there is, as Marco said, obviously we are not, I mean, I don't think we have made huge investments in point cloud in the last few years, but that is a technology certainly that is important to a lot of our partners. So I think there's more beyond just new format updates. There's more features on the horizon, performance improvements, other other improvements, I would probably say we should have this ability to more dynamically inject point clouds to an existing point cloud, so we can better support like dynamic scanning workflows and other stuff. But that's all. Yeah, don't think anything has been decided on that front. Okay, so let me just get set up here to get. So here's a HBS OOC demo application, which is a good test environment for testing your point cloud data. And this point cloud I created out of 3 individual point cloud models to get to like a certain size, about 150 million points. And you see here it's very complex. You see that the functionality of the point cloud in action as you're going through the model, it will load and unload the relevant data. You can kind of see it as that as you're moving through, some stuff gets reduced and some stuff gets loaded in. And you can also control how much memory the system is allowed to use in the demo that's implemented with this OOC memory slider on the left. Now, this point cloud is fairly dense, but as you zoom in, you see it gets a little hard to see. So that's why we have the splat rendering, where you can control how large individual points are actually drawn. In that case, they're drawn with sprites. So that gives a lot more solid representation of even like relatively sparse point cloud data, and you can control the size of these splats as well, depending on what the data looks like. And you can enhance the visual quality of the point cloud even further by turning on IDOM lighting. That's mostly for point clouds which don't have already light or color baked in, but even here you see it just looks a lot more like a really 3D triangulated model if you activate this IDOM lighting feature. And finally, while the internal frame rate logic should keep performance at a pretty good level, you can also still manually control how many points are actually drawn with this vertex decimation settings. Let me show one other thing very quickly. Again, that pre-processing step. So I made a quick example here to run the preprocessor just to show you what actually happens. So here I have a simple XYZ file containing point cloud data, and so with the old process with the executable, you just run this with the F option, which loads the file in and then automatically creates all the relevant data. So that only for this file is relatively small, takes a few seconds. And then the result of it, again, is this OOC file. That's the one you actually load. And then associated to that, based on the file name, you also have these kind of additional directories which contain the optimized structure of the model. So every time you're generating an OOC file, you end up with at least one file, the OOC file, and then 2 directories for containing the structure data. And then if you're creating these delta files, if you're actually editing or modifying something in the model, you will also have an additional delta directory in here as well.